Hi guys, welcome back to my channel Mr. Electron, and this what you see is a car alternator. Not just any car alternator, it's a BMW alternator with the current value of up to 180 amperes. That is why it is so special. And how I know that, I'll show you on its label. So guys, here as you can see that it's the value alternator, and it's also printed BMW 14V meaning volts and 180A meaning amps. So it is 14 volts 180 amperes. Now guys, this alternator stopped working, so to be sure we will have to look into it. Well guys, this one seems like a perfect fit. Yeah, it's an 8mm. Okay, got this piece out. Here you can see this saying B positive, which is the main output positive terminal of this alternator. Well, the brushes seem fine. I will give you a close-up. That's the rotor slip rings, and if you look closely, you will see the brushes. Okay, so guys, it's time to do some winding check. You see this and these three terminals. These are the wires coming out from this winding, copper winding, which is the armature winding. Okay. So let's check the resistances. Oh, the resistance is quite low. It is around 0.2 ohms. That's pretty low. Let's go for the other one. Yeah, this one also 0.2 ohms. Now comes the far ones, again 0.2 ohms. So yeah, the alternator is working fine for the armature at least. Now that's left is the rectifier. Well guys, now comes the part of finding the fault in the alternator, if there is or if there is not. So first we are going to do the self-excitation testing. Well guys, I'm also going to measure the current of this high current motor, 1.5 HP. Let's see how much it draws. Okay, so yeah, let's start the setup. You can see that the setup has started, and if we measure the current that this motor is drawing, okay, it is drawing 0.19 amps at around 70 volts. That's pretty efficient. Well guys, this time I'm going to connect the multimeter terminals to check if it generates some voltage and if it is getting self-excited. Since entire body of the alternator is a negative, so I'm going to connect it to the body, of course. Okay, so turning it on. Well guys, here as you can see that it is generating around 0.6 volts DC. So all I have to do is increase the RPM of the alternator and check if it can self-excite. You can see that the voltage on the multimeter is increasing. Pretty high volts, almost 1 volt, close to 1 volt. That is almost 1 volt. Yeah, it should get self-excited now. I don't know why isn't it getting self-excited. Let's go a little higher and see what happens. That is 1.7 volts. Still nothing. Turning it off. Well guys, finally I will have to take this part out. You see 1, 2, 3, these 3 screws. Let's open them. Let's see what the problem is. Nice and easy. Okay, go. Well, the brushes as you can see are pretty good. Not a single problem. Well, this what you see, these are the slip rings for the rotor inside, or you can say the field winding. Let's check the field winding if it is working or not. So guys, for testing the field winding, I'm going to use this 15 volts 3 ampere supply, and let's see if there is a spark when I connect these to the slip rings, or touch it to the slip rings. That would be more appropriate. Yeah, there is spark, no doubt. So the field winding is fine. Let's make sure that there is no short circuit by ensuring the availability of good magnetic field. The field coil inside is really inductive, and as soon as I remove one terminal, it is going to give a good flyback. So there's still hope for it to be tested. Let's do it like this. Okay. Yeah, good magnetic field is being formed. I can feel it when I rotate the rotor. Yeah, the magnetic field is pretty good, which means the field winding is perfect and the slip rings are also fine, so there is no fault here. Well, let's open this case type thing and see what is inside. Maybe the fault is in here. You see here, it seems like the electric cable bus power system, and this entire circuit is filled with some kind of gel, you see. So guys, it seems like this three-phase rectifier is fine, but there is some problem with this voltage regulator. Maybe the diodes within this have stopped working or something like that. So anyways, there's always a solution or a shortcut to situation like these, which is this. So let's remove it. This is going to be the direct positive terminal for this alternator. Okay, almost out. Okay, finally, as you can see, this one is the positive terminal for the brush. So I will have to give a solder over here and extend a wire or something like that. And about this, let's just cover it as it was before. Okay, yeah. So guys, here I'm going to use this red wire to add to the new brush slot or connection that we just opened. That's the positive one. That's done pretty good. So placing everything back as it was before. So you get a screwdriver thin as possible, and then push the brushes so that it creates space for the slip rings. Okay, first one done. Now the second one. Yeah, second one also done. Now all we gotta do is tighten up the screws.
Okay.
Yeah, it's running smooth. So guys, for confirmation, let's just check the resistance of the field winding or the rotor winding, for which the positive brush that is feeding the field winding is this one, and the negative is the body of the alternator. Yeah, the resistance is 9.4 ohms. So the coil is fine. Once again, the magnetic field check. Positive will be given to the red terminal and negative is the body, you see. And now we are in business. So let's connect it like this, and yeah, pretty good magnetic field has been established. And I remove it, it's free to run. Okay, look closely to the shaft, and it has become hard. You see, it is asking for a lot of power to operate, and when I remove it, then it will run really smooth. So guys, the final check will be completed by finding out if it is generating electricity or not. So yeah, this is a 55 watts bike headlamp bulb, 12 volts, 55 watts. So one terminal here I'm connecting to the positive. Okay, done. And this side will be connected, as I said, to any part of the alternator, since the body of the alternator is negative. Yeah, so that is also done. Now for feeding the rotor or field winding, again the negative will be connected to the body of the alternator, done, and positive to the brush. Okay, done, you see. And guys, here I'm feeding the field winding or the rotor winding with the laptop charger, 15 volts output. Okay, go. Wow, well, this is working pretty good. Again, and this time a little harder. Nice. So guys, here as you can see that I've turned off the lights once again. Okay, go. So finally, it's time to finish off the video. The alternator is perfectly fine. We can use it now for generating electricity or anything like that. Let's disconnect this one. The electricity is getting wasted and the field coil is getting heated up. And in the upcoming videos, I might go to the self-excitation part of this high current alternator and also check the loads it can operate. Okay, see you in the next video. Bye bye.